Oh, I'm live. Oh, okay. I was expecting something else, but hey, everybody. I'm Anna. I'm the co-host of a podcast called Zero Knowledge Podcast. I hope you have heard of it. If not, please check it out. And for today's panel, we're going to be talking about SNARKs on other ecosystems. And I have four fantastic guests who I'd like to introduce: Ariel, Barry, Marco, and Kobe. Welcome to all of you. I guess you're just waving. Let's do some quick intros to sort of get people to know you a little better. Ariel, why don't we start with you?
Hey, Ariel Gabizon, right now working at Aztec Protocol. Before that I did some work at Zcash and Protocol Labs.
Cool. How about we go next with Barry?
Hey, so I'm Barry. I do a lot of work with zero knowledge proofs in the Ethereum ecosystem, and I work to use zero knowledge proofs for scalability and for privacy. And I'm especially interested in doing kind of privacy applications to things other than financial transactions. I think there's a lot of really interesting things we can do there, and I'm very excited about seeing those come into production.
Very cool. All right, next up, let's hear from Marco.
Hello. So I'm Marco. I've been working since 2018 on Tezos. I worked on most of the amendments of the economic protocol. And then I founded, together with Marc Bernardo, the privacy team at Nomadic Labs, and we've been working on the integration of sapling into Tezos. Many thanks to the ECC and Zcash for the excellent work. And since then, we've been working on our own implementation of a plonk proving system that we hope to use to do a zk rollup soon.
Very cool. Kobe, let's hear from you.
Hi, I'm Kobe Gorkan. I'm cryptography lead in C Labs. So we have, we're working on Celo, and we have quite an extensive, cryptography stack that includes things like VOPRFs and TKGs, but our main SNARK project that we've been working on for the last few years have been this Plumo project, which is a SNARK-based light client. I'm looking forward to, this is an aspect that we're using SNARKs for scalability, but I also think that SNARKs for privacy are a great and important use case. So, yeah.
Very cool. Ariel, can I come back to you? Because I feel like everyone else described a little bit more the kind of ZK that they're working on, but you didn't. So why don't we hear from you about what kind of ZK stuff are you doing over at Aztec?
Some of our work has been on making proof systems, especially with universal setup. That's what led to the Plonk zk-SNARK. We're basically working on privacy and scalability on Ethereum. Specifically right now, something we're excited about is, for example, calling these expensive contracts, like DeFi contracts like Uniswap, in a way that people split the fee between them, and also they remain private.
Kind of like the private DEX space a little bit.
Perhaps. I don't know that space well.
So it sounds like Ariel and Barry are both working in Ethereum, Kobe's in Celo, and Marco's in Tezos. And I guess I'm kind of curious, in each of those ecosystems, where would you say the focus is for ZK tech? And maybe we'll start with Ariel and Barry for Ethereum. What are the focuses maybe in Ethereum for ZK tech at the moment that you're maybe interested in thinking about? Yeah. Barry.
So at the moment there's, I guess there's two kind of directions. There's one direction about making sort of private applications. So some examples of that are Tornado Cash and I think it's Z Money or ZK Money, the Aztec private transactions, which is a ZK rollup. And that's one direction. And the other direction is for scalability. So there's a lot of ZK rollups at the moment that are doing like application specific rollups, but there's also interested in making like ZK rollups that can support smart contracts, which is a pretty complicated task. And it's also pretty interesting to explore the possibilities there. Personally, I'm interested in both of those things, and I'm also interested in making things like private reputation systems and private like social graph, proof of social graph connections. I think both of those are pretty interesting as well.
Cool.
Yeah, I'd say, yeah, in addition to what Barry said, something that's maybe not as philosophically interesting, but I think will be the biggest sort of push for the technology is just reducing fees, right? Fees on Ethereum right now can be hundreds of dollars, and you know, having a decentralized transaction where you can split the fee amongst you know, as it happens in rollups between many participants, but still have the same guarantee of trustless guarantee of the correct execution. I think that's going to be sort of in the short-term practice what's going to push the technology forward, and sort of is a pleasant positive side effect of things like rollups.
Cool. Kobe, in the case of Celo, the Plumo setup, it's not like scaling in the way that we think about, like it's thought about in Ethereum. But tell us, like is that would primarily the focus in the Celo ecosystem?
Yeah, that's a great point. So maybe to give a bit of background, like where ZK rollups, like Ariel said, you give users the opportunity to share fees and then have higher transaction throughput. In contrast, the way we use it in Celo, where Celo focuses a lot on accessibility and giving users with mobile phones the ability to connect to the network in a way that they don't have to trust anyone. The Plumo system allows them to synchronize to the network really fast and get the full guarantee of a light client. So maybe that's pushing the scalability front a bit hard. It's not the exact term. But yeah, that's one aspect where we invested a lot of efforts in with SNARKs. But definitely the Celo community is interested in seeing how to get things like private transaction, private smart contracts, and even, you know, more traditional scalability like rollups into that ecosystem, because, you know, when you have these good problems, then you need all of those solutions as well. But yeah, that's kind of where it is.
Would you call it, so, you know, it's not scaling the way ZK rollups are, would you call it compression? I know it's using like kind of recursion, but like, is it, I've used that before, but I don't know if that's actually how you refer to it.
I think it's a great term. I remember seeing one talk, like one of the first talk about SNARKs, where Ellie used the term like blockchain compression when they discussed one of the major applications that SNARKs could be. So I think that that word fits really well with what Plumo does.
Cool.
With the specificity that this is for light client, like compressing the light client protocol.
Yeah.
Yeah, that's nice. A great point. Yeah.
Okay, Marco, I want to hear more about the work that you've been doing. So in the case on Tezos, would you say like the focus is very much on just the private transaction, or there's some like other ideas that you're trying to incorporate into that?
So right now with the sapling work that we did, yes, I would say that the main use of SNARKs is for privacy. Right now we've changed a little bit the focus to go on ZK rollups, because well, the main goal for the Tezos chain for this year on the roadmap was to increase the transactions per second. And it was decided that rollups were the right way to do this, optimistic and ZK. The reason why and this is not a novelty, everybody's doing this. What excites me about this is the fact that, especially with respect to optimistic rollups, is the fact that we can do away with the data availability, and we can have a very simple interface between the main protocol and the children zk rollups, and which opens the door for more well, to go crazy and to implement as many things as we like without having too many constraints. And so this is very nice to experimenting. So I hope that this is going to be great for scalability, of course, but it's going to be good for modularity, being able to say to a client, you want to do an NFT market, we can build a specific rollup for that, and you don't need to pollute the main chain with whatever it is that you're doing, maybe. So this is interesting to us, and this is opportunity also to. So once we have this infrastructure in place, to do privacy inside the rollups. So of course, the next step would be do a sapling-like protocol rollup, where you get privacy. Where you get privacy with respect to the validators of the rollup and of the users of the rollup.
Cool. What would you say, this is actually a question to all of you, where do you see the sort of push for ZK research? Do you see it primarily coming from the privacy side or from this other side? And this is kind of a question to all of you. This is also kind of looking historically, like what has really pushed this research? Maybe I should call on you, actually, because you're all muted. Barry, I'm curious what you think about this. What do you think pushes the research?
So originally, privacy was the main application that pushed the research, right? A lot of the work that we're benefiting from in the Ethereum ecosystem is coming from the work that like Zcash community has done, and we're very grateful for that work, and especially their openness to publishing and releasing all of their really cool ideas. So originally it was privacy, but I'm starting to see more interest from the scalability point of view. Just because like there's a couple of ZK rollups, but okay, so the major problem I see at the moment is trying to make smart contracts work in ZK rollup for scalability, right? It's okay to make like it's possible to make a ZK rollup that's like automatic market maker, for example, but making things that are programmable is very powerful, especially in the Ethereum ecosystem, where it's the ability to have smart contracts is just like one of the most interesting things. So that's where I see things at the moment.
Cool. Ariel, would you second that?
Yeah, I mean, so I guess I'm going to repeat my first answer. I think the large fees are going to push the research forward. And yeah, relating to what Barry says, so I think we're already more or less at a point where for a fixed contract, call to a fixed contract like Uniswap, the ZK technology is good enough, and we hope to have something out on that front pretty soon. But and right now, I think the pressure is for things like Uniswap, right? People are spending really large fees, and I think if there's going to be a similar urgent demand for custom contracts, I don't know if that exists right now, that people want to call their custom contracts all the time. That's going to push forward this research on zk-EVM and being able to practically with a fast prover compile an arbitrary like solidity program. I know there's already some work on this front by I think Moderator Labs, but I think and also that's something we're interested in. And I think when they'll be like with Uniswap, that people are willing to spend hundreds of dollars all the time, when there'll be a similar pressure, and high demand for custom contracts, that's going to push the ZK, the ZK systems to be able to implement zk-EVM. That's going to push it really hard.
Cool. Kobe, do you have any thoughts on that?
Yeah, just a bit. So I think I agree with Barry and Ariel that a big push came from the privacy front. Like when Zcash productized the zero cash construction, that was amazing for getting this out there and getting more people researching these technologies and developing new things. I think that if I remember correctly, on the research side, there were actually other fronts that were explored at the same time. Like I think one of the papers is like SNARKs for C, where you actually wanted to prove the correct execution of a program. So it's kind of like offloading computation to someone else. I think that was one of the use cases that were discussed at those times before things were practical. And maybe that kind of in some ways similar to VM constructions today, or even rollups in some way. But yeah, I think like we see a lot of research on both fronts today, like higher level applications like AMMs on contracts that you want to be private, and VMs and identity work. So I think both of them push pretty good right now.
Marco, do you want to weigh in on that?
Yeah, I don't know, maybe I have a bit of a different point of view. I think if the question is what is funding this work on zk-SNARKs technologies, I think I agree with all the answers that were given. If you were just talking about a more generic pushing the state of the art, I think it's just the love of cryptographer, the blind love of cryptographer for magic. Like they just love this, and they just want to see how far they can push it. I don't know. I'm not a cryptographer, so this is at least how I live it from the outside. And I think the proof of this is the fact that there is a very nice cross-pollination between industry and research, which is something that usually doesn't happen. Like if you're trying to solve concrete problems because you want to make money, or you have just a concrete problem, researchers usually don't really bother. The fact that there is this much exchange and everybody is interested, I think it's the proof that they care and they like it.
There's something to it. I want to ask kind of a question to everyone here about how you deal, because the name of this is SNARKs on other ecosystems. So I'm curious how everyone in everyone's respective ecosystem is dealing with the trusted setup for these SNARKs. Let's start with, actually, Marco, let's start with you. Like, yeah, what are you guys doing for a trusted setup?
So we're planning, so we cheated and we plan on doing it again. So when we took the sapling protocol, we integrated it, we used the same trusted setup. So we can thank again the Zcash for doing that. And then, so now with the Plonk system that when we're going to release the first circuits using this new Plonk proving system, we're planning to use the same trusted setup again as a universal setup. So
cool. Kobe, I kind of know the answer to this one. What are you doing for a trusted setup?
Yeah. Right. So in the Plumo case, the situation is a bit hard because we both are using SNARKs on a large curve, like 760-bit curve, which is the BW6 one. And we're also using a very large circuit, like 2 to the 27 constraints. And that poses a lot of challenges in terms of how much time it takes for contributors to work. So it takes like potentially days for each contributor to contribute their randomness to this whole setup. And since we're still using the Groth 16 system, then we have 2 phases. So if we wanted really decentralized and a lot of participants joining in the setup, then we would have to spend a lot of time to get a good amount of participants. So to cope with that, we actually created the Sparrow system, which is based on an idea that Justin and Vitalik posted on ETH Research, which makes the setup itself optimistic. So you divide the setup into rounds, and then basically each round participants can contribute in parallel. So it's allowing you to increase the throughput. There are some, of course, compromises in terms of the liveness of the setup, but it's as secure. And yeah, we also had to automate this whole process. And yeah, we actually are running the phase 2 of the Plumo circuit setup. We're starting it very, very soon. And I hope that everyone listening will join in.
Totally. And I'm helping that project, which is why I know something about it. So that's the Plumo phase 2 trusted setup happening very soon. If anyone wants to run one, if you haven't yet, or if you have run one, see how this kind of new innovation runs, it might be interesting. I want to, and if anyone in the chat has the link, that would be super cool to share it. I want to move on to Ariel and Barry and what trusted setups in Ethereum. And actually, Ariel, you have experience with other trusted setups too. So I'm curious, how does it work in other places?
I helped a little with the Filecoin MPC. It's definitely much harder when the parameters are large. Aztec did an amazing job at what they call the ignition ceremony. That I wasn't there yet, so I can't take any credit. It was this fortunate thing that the ceremony was for the Aztec 1 protocol, and it turned out that Plonk can also work with the same parameters.
Oh, phew. That's amazing. I didn't actually know that. That's great.
What makes Plonk a little easier is that compared to Groth 16 is that you only need points in the first source group. So both the parameters and the computation time of the participant is smaller. I mean, when I was helping with the Filecoin first phase, really practically we could only have participants with these 96 core, with these huge machines. Whenever we tried someone with a laptop, it was like, all right, you're not done, and we need to go to the next participant. So maybe another time. Yeah.
Cool. Okay, let's hear from Barry about, and I think you could speak about this, right, Barry? The perpetual powers of Tau, the thing that's happening over on Ethereum.
Yeah, so this is a project by Weijia Cole, and the group is doing this kind of perpetual trusted setup. So basically for the curve BN254, we're running a trusted setup. It's 2 to the 27, 28 constraints, and it takes a long time. It's a long time to contribute to it. And this is phase 1, so it can be used for Plonk, and it can be used for Marlin, and it can be used for Groth 16. And then for phase 2, we have a simple user interface that people can join and do trusted setups for their smaller circuits. But yeah, it's something we're trying to solve at a community level, because there's a bunch of different projects that need to do this. And so we're trying to do that and build trust. We also want to do it for other curves with BLS 1231 and other things. But this is something that's been going on for the last several months, maybe even a year at this stage. And yeah, it's open to contribute anytime. People can go and contribute right now. And hopefully someone will put the link in the chat. And yeah, people can go and participate if they're interested.
Also, I'm not going to shill the podcast too much, but last year around this time, I actually did do a series of I did an episode with 4 different interviews all about trusted setups. And so if anyone is curious about how that was working, including the ignition one and the perpetual powers of Tau, yeah, check it out. I don't remember which episode number, but it's last year. Okay, there's a question that I have been quite excited about. But as I'm looking over the questions, I'm we wanted the history, the use cases, what's pushing it. But what I really want to hear is what's super exciting for all of you in the ZK space. And maybe we can start on the use case side, and then we can go more into the technical. And I know somebody, I think Kobe, you already mentioned the private reputation systems, or maybe Barry, one of you mentioned this. Someone I think in the chat already highlighted that as interesting and are looking for references. But yes, let's talk about the other ZK cases, new use cases coming, maybe even just being considered right now. What's exciting?
Yeah, so I shared a link about the private reputation system in the chat, and there's more information there. Roughly, the problem is that you need to be able to like risk your reputation in the private reputation system. We come up with a way with like these kind of epoch transitions so that you commit, then you can win or lose your reputation, and you go to a new group where you collect your positive or negative reputation. That's one interesting use case. Another interesting one is private social graphs. I'm really excited about building this. So it's a way to, so with Facebook, you have this kind of weak kind of reputation system where if someone's a friend of a friend, you kind of trust them a little bit. And like, this is cool, but it's transparent. I think we could build like a private version of this would be much, much better. And I had some ideas about how to do that, but I don't want to take up all the time.
Cool. Anyone else? Weird out there ideas?
So this is really not something that I concretely have any plan on. But I think it's interesting. It's connected to what Barry was saying. I think the notion of identity should be, we should bring back the notion of identity on the world of blockchains, and stop with this address pseudonym Far West. I think so. One way of doing this. So what Barry was saying reminds me of the Web of Trust, the stuff that we would do with the PGP and like two parties where you sign each other's public keys and stuff like that. So this would be a way. The other thing I'm curious about is anonymous credentials. And I'm wondering if we could take some of the huge literature that is out there and use it together with the new proof systems, zero knowledge proof systems that we have today. So I would be curious to see something done in that space.
Cool.
I can also weigh in. So I agree with Marco about identity. I think it's an area that is super interesting to get into, like to reintroduce into this ecosystem. And there's a lot that SNARKs and zk knowledge or related technology can help there and can give a lot of benefit to people. So I'm all up for that. I think all of the recent work on like privacy with AMMs is also pretty interesting. And maybe one use case is that was just so fun and new for me to experience was this Dark Forest game. That was a really cool use of SNARKs that I think Brian did an amazing work in getting out there. So yeah.
Totally. Ariel, do you have any ideas here? Use cases?
Well, I mentioned our focus now is the sort of privately and cheaply using DeFi. In terms of use cases, a big thing that caught my eye in the last year was this thing called Deco, where you can sort of prove to someone that you have at least $10,000 in your bank account, and you do it in a way that your bank is participating, but not knowing that he's proving to someone. The bank just thinks you're having a regular transaction with them.
This sounds, so I have a few like listed other ideas that have been floated around, and I think that one falls a little bit under that like selective disclosure idea, where like somehow some information potentially from an institution could be shared, or vice versa, something could be shared with an institution, provably, but privately. I wondered if anyone's had any other ideas around this compression idea, like ZK for compression, maybe outside. I mean, so far we're like, there's the roll up, which kind of compresses transactions. There's compression of the light client, but is there any other compression topics that you've seen? This is me partly mining for new topics to have people on the show, by the way. So this also goes out to the audience if anyone has any ideas of these. But yeah, have you heard of anything or thinking of anything?
I'm wondering if it could be, well, some similar to what Ariel was saying about Deco, the fact that maybe you want to prove something about, say, about your bank account. So there would be one proof. Or maybe you're trying to build a file about yourself or something that is more complicated. Maybe you have a company that has, I a bunch of other companies that are supplying products, and you would like to prove that all your suppliers are doing their job, and their supplier will give you a proof that they're doing that job. So you have this sort of recursive structure that would preserve the privacy of everybody, but it will still prove, I don't know, to the last customer that no child labor got into that T-shirt.
Cool. All right, let's hear some exciting ZK topics, more on the deep tech side. What are you excited about in that regard? Ariel, you're jumping in, I'm happy.
So,
great.
I jumped. Yeah, so one thing that I think is super interesting is now that we're in this age of rollups, everybody's doing rollups. So you've got, right, in this rollup scenario, you've got this one proof that a weak client is proving, but is never put on chain. And you've got a proof where a very powerful rollup provider is doing the computation and is being put on chain. So, right, we've got these ZK proof systems, and they all have their different pros and cons. And I think a really exciting thing that is going to get a lot of attention, should get a lot of attention in the next years, is let's mix and match. Let's have one proof system for this client that the proof size is totally irrelevant. It can be huge. It's never going on chain. It doesn't matter. And right, and then let's have the rollup provider maybe give them a proof system with where the proof computation is expensive, but the verification and proof size is super small, because that's what's going to be super expensive, right? Everybody who's validating the blockchain is going to have to verify this proof. So that's, I think, a super interesting direction where we can look at these proof systems with linear time instead of quasi-linear time that have large proof lengths. And okay, maybe we can use them or partially use them for these client proofs that are never put on chain. A little more into the weeds, I'm really interested in, this is very much into the weeds, range proofs. Can we get more efficient range proofs? The Plookup paper made some progress with this, but I don't think it's the last word. And more into the weeds, one more thing. So there's this function, Dara talked about this in Samia, if I'm saying it correctly, this sort of variant of Peterson. We have a sort of similar thing in Aztec. Can we get like better? So like since Samia does a double in add, elliptic curve double in add for each like 10 bits of the input, can we make that just an add? In our version, it is just an add, but we pay with much more lookup tables. So can we get just one 10-bit lookup table and only one add instead of double in add for each 10 bits of the input? So, or, summing that up more at a high level, can we, these different gadgets we have, range proofs, hashes, how much can we stretch them? And now that we have these more flexible ways of doing constraints, we don't have to do it just in R1CS. So yeah, that was my jump into the question.
That sounds great. Anyone else?
Yeah, so I'm really excited about SNARK-friendly primitives, but actually going on the other side, I'm even more excited about bringing back all the classic primitives that were completely untreatable before. So I'm hoping that with the new improvements of that have been doing in Plonk, for example, we'll be able to do cheaply Blake or ED25519, and so at that point, even if there will always be more expensive than SNARK-friendly primitives, it means that I can start talking about concepts that exist elsewhere, not just in the SNARK world. And so I think this is very interesting because anyway, after all, everybody is using other kind of crypto. So if I want to talk about if I want to prove something about a hash that is out there, I need to use their algorithm. And this goes together with the Deco line of work. If you want to talk about, so I think in that work, they're really suffering through you have to use the crypto of TLS and stuff like that. So once you make that possible, you open up a new world of possibilities.
Cool.
I think that, oh, sorry, Kobe.
No, go ahead.
That was me saying cool. Go ahead.
I think like the thing that I'm most excited about, or the thing that I think is going to like unleash a lot of potential applications, is recursion. I feel like we're just getting to the point now where we have some recursive proofs being verified on Ethereum. And with that, it will come a lot of possibilities to build like more complicated things, which I'm very excited about.
Yeah, so I guess like continuing on that thought, I think that recursion is exciting. It could build a lot of interesting new use cases. And I'm also interested to see some constructions that would take the current very efficient recursive SNARKs and would eventually, bundle them up in some more efficiently verifiable SNARK, like these things that were called, I think, lollipops a few years ago, but were less practical back then. And maybe on a similar note to what Ariel said, I want to see constructions that talk more about offloading computation of the proofs, but in a private way from a weak mobile phone to some powerful server, but without giving away your location in the tree or things like that. Those kind of interesting constructions could open up a lot of new use cases. And yeah, I think also just the combination of technologies that maybe some things that you can combine NPCs with SNARKs in a very clever way. So some, I don't want to take up the whole time, but some things around that, yeah.
That's actually my next question, which is like, are you seeing SNARKs being combined with other privacy technologies? Like, and I don't even know if it would make sense to combine with FHE. Maybe that's more competition, but with MPC, like, is this also something that you on your teams are actually playing with, or would you say this still lives kind of on the edges in research?
So just before I start, just a note that you have to be very careful with MPC, multi-party computation, because there's like different kind of trust assumptions there. There's like most MPCs are like 66% honest guarantee or something like that. There's this difficult trade-off where you can have like, you need honesty, but you also need liveness, and you can't have like strong one without the other. That being said, yeah, we've been doing some work with multi-party computation. So me and Kobe actually worked on this idea called Blind Find, which is for the web of trust, where you have this kind of private social graph, and you do multi-party computation with each member of each of your peers in your social graph, and you use that to search for someone who you're connected to. So, and then we do like a ZKP to prove that this connection exists, and you can chain these connections together to make this kind of proof that you have a certain path in your private graph. So we've been doing that, and we've also been like, one of the real tricky, I'm sorry to take up so much time, one of the real tricky things about private smart contracts is to sort of find someone that you're like pairing with. If you want to do a private exchange, you need to find a peer who wants to do the opposite side of the exchange. So me and Kobe have also done some work to try and find me and Kobe and Kevin have done some work to try and find these kind of traders, people to trade with. Yeah, doing some MPC stuff, but that's all we have so far.
On your side, Ariel, is anything happening in Aztec in that regard, or are you not looking at that?
No, nothing yet on my end. Yeah.
Got it. Kobe, did you want to say anything more about that, or because I have sort of like one more question.
Maybe, so I won't talk about that aspect, but maybe one other technology that is interestingly being improved during recent years is this whole simple kind of MPC, which is DKG, is like distributed key generation for threshold cryptography. So I have yet to see whether SNARKs can improve things there significantly, but maybe. And we've evaluated using that. Like we've evaluated using SNARKs to improve DKGs in the past, but eventually we found that more specific zero-knowledge proofs can do much better.
Cool. There was a question in the chat that I'll just bring up now, which was actually about who is working on identity with ZK. So I don't know if Barry, I think you have an answer to that. I'm trying to think of like other examples. Who in the ecosystem would you say is working with identity and ZK?
So at the moment, we are working with some identity stuff. We have a couple of projects to do with identity. That's so. Who else? Kobe, do you know of anyone else?
I know of a few. I'm not sure how public all of them are. So I don't want to name anyone that I'm not supposed to. But yeah, I will just say that I think that if you want to work on identity with SNARKs, reach out. I think that could be interesting to the Celo community.
Oh, cool. I did have, I think last year I had someone on the I had a team on the show called New ID, and they use ZKPs for passwords actually. And so that's how they're kind of creating these identities along with these passwords. So that's also maybe something to check out. Okay, so if there are any questions, please leave them in the chat. I think we have like 3 more minutes. And I have a question for all of you, which might actually be a stress point. But what's it like hiring in the ZK space? I don't want to touch a nerve, but I know it's tough. But yeah, I'm curious to hear what it's like in the various ecosystems you're in.
Well, I can jump on that.
Sure.
We've been growing a small team in the past year, so I know that how hard that is. Actually, sorry, and plus we work in OCaml, which is kind of another aligning the star kind of thing. Anyway, it's been surprisingly good. You really, so when you select a lot, you have very narrow requirements. You have very few people showing up. For a long time, you don't get any people. But when they do, they're usually very good. So I think there's hope.
Cool. Anyone else have any ideas on that?
So I can say that, being involved in the community, like working in the open, has a lot of benefits that it brings good talent to you. And so like Marco said, when you get those people that found you through this community, or I don't know, that's not what Marco said, but when you get these people, they're very good. So I do think that there are a lot of levels in the stack. So when you deploy SNARKs, it's not just writing a circuit. You also need to write a proving server. You also need to write some this trusted setup. You need to do a lot of different levels. And the problem is that a lot of the cryptography leaks throughout the levels. So it takes some time to onboard like people with different experiences into this entire end-to-end stack. So that's sometimes hard.
Yeah. Any other thoughts?
One thing that's really nice is seeing people pop up and just starting these really cool projects independently. It's really nice just to see that happening over time.
Okay, last question, and we're gonna end this. But do you think we're ready for a ZK focused hackathon? Do you think we're ready for it? Do you think that could actually, like, is there enough now to build stuff in a weekend? What do we think?
I mean, personally, maybe this is a deviation from your question, but personally, I'm still more interested in sort of building the basic infrastructure. And one thing I think we need to focus on, especially with the universal setups, that there's no like 3-month code freeze to audit, sort of creating syntaxes and mechanisms that someone that is not a ZK crypto person, the probability they will make a bad mistake is small. So how to make syntaxes and such that sort of force that, make it really hard to make bad mistakes.
Cool. Okay, so we're at time. I think we're getting we're getting dragged off the stage here. I'm still going to throw it out there. ZK Hackathon. I want to hear from people if they think that we could actually make this happen, maybe this year, maybe in person. Anyway, I want to say thank you to everyone who was here on the panel, and thank you all for watching. See you from
Thanks,
the other
everyone.
ecosystems.
Thank you.
everybody.